All right, so I finished out the rest of my graph, okay, and you can see I've got two nice full curves at the top and half of one here, full one, and then another half of one. So I'm going to go on to number 2. Use a green pen or pencil to mark one full cycle on the graph. Now basically, this just means from one spot, the pendulum moved back and forth and back to the exact same spot. So I'm gonna mark mine on the equilibrium line because I know that it has to hit that center point at some time. So I'm gonna just start with my very first one, and I'm gonna mark it right here. Now there's two ways that you can do this. You can follow the graph all the way up and down and back, or you can just draw a straight line. In my case, I'm gonna just draw a straight line. So my pendulum was here. This is the middle part. This is going away from the motion detector and back towards it, back at that equilibrium, but it hasn't completed a full cycle yet because remember it has to go back and forth, okay, one full time. So here it's coming toward the motion detector and then it swings back to the center. So here is the end of my full cycle, and I'm going to just kind of shade in that line so you can see it a little bit better. So one full cycle is from equilibrium back and forth to the equilibrium again. Number 3, use a red pen or pencil to shade areas where the pendulum swung toward the motion detector. I can get my pencils out here. Now, if this is the equilibrium point, when our position is getting higher, okay, this is our number of meters away from the motion detector. When the position is getting higher, that means that it's swinging away from the motion detector. When the position is getting lower, then the pendulum is swinging toward the motion detector. So every time this line goes down, the pendulum is swinging toward the motion detector. So I'm going to shade in that entire half of that little hill there. And then it swung toward it, and then right here again, I'm going to shade in kind of that entire half underneath it. I think this line should curve up just a little bit more. So it went away and back towards it, and away and back towards it. Number 4, use a blue pencil to shade areas where the pendulum swung away from the motion detector. So that's every time the line is going up. So I'm going to shade the other half underneath this little hill with the blue. And it doesn't have to be beautiful. Just enough to get your point across. So every upward hill like this is going to be half blue and half red because it was going away and then back toward the motion detector and then away from it and then back towards it. Now here's the tricky part, the math part. Based on your graph, what is the period of the pendulum? Now remember, period is how long does it take to make one full cycle. So we're going to go back to our data chart. Okay, and remember we figured out that our equilibrium, remember way back, we did the math, we found the average of this and found that our equilibrium point was 0.302. And I know that it hit that somewhere just after 0.2 seconds. So I'm going to go back to my data chart, if I can get it to show correctly. And I'm going to go somewhere around 0.2 seconds. Okay, right in between 0.25 and 0.3 is where it hit that equilibrium point. So I'm going to start with this right here, 0.3 seconds. Okay, 0.3 seconds. I know that my position was 0.305 meters. And the end of that cycle is somewhere around 1.6 seconds. So I'm going to scroll down on my data chart here. Move it so you can see it. Okay, here's 1.6. And look at that, 0.306. I would say that's close enough that I can use it. So 1.6 seconds at 0.306 meters. Okay, so it took from 0.3 to 1.6 to go all the way back to that equilibrium point. So I'm going to come back to my calculator if I need to, and I want to know just how long is that from 0.3 to 1.6 seconds. Now you should be able to do that in your head, but just in case, take the big number minus the small number, and it took 1.3 seconds to make one full cycle. So the period is 1.3 seconds. Frequency, okay, is how many cycles does it make in 1 second? And remember, that's the inverse of my period. So I can say 1 over 1.3 seconds, and if I do that math, 1 over 1.3, 0.7692, blah, blah, blah. And we're going to keep that to 2 significant figures because I've only written 2 significant figures here. So we're going to say 0.77, and remember our units for frequency is hertz. So this is my frequency, this is my period. Amplitude of the pendulum. Amplitude is what's the farthest it gets away from our equilibrium point. Remember, we decided our equilibrium point was 0.302. So we take either one of these, our maximum distance point minus our equilibrium point, and that'll give us our amplitude. So 0.355 minus 0.302, 0.053. That's our amplitude, 0.053, and it's in meters because that's what we're measuring in here. That's our amplitude. How far away does it ever get from the equilibrium point? Now, the maximum speed of the pendulum, okay? Really, this should say average speed, not maximum speed. We're going to do the average speed. Average speed is going to be the total distance traveled divided by the total time that it took. So we're going to go back to this period, this one cycle, okay? In order to complete one cycle, how many times does the pendulum complete this amount of amplitude? Well, it goes away and then back. That's twice. And then it goes away and then back. That's 2 more times. So it actually completes that amplitude 4 times. 1, 2, 3, 4. So our distance is going to be, and I'm going to write it underneath, is our amplitude times 4, because it does it 4 times. And we're going to divide that by our period. It took 1.3 seconds to travel this far. Okay, so if I multiply out that math, I've already got that amplitude still in there, so just times 4. So 0.212 meters. That's the total distance that it traveled, divided by 1.3 seconds. Okay, so I'm going to take this, divided by 1.3. Gives me a speed of 0 point, and we're going to keep it to still 2 significant figures. This is an actual measurement, but we only had 2 significant figures in the other one, so we're going to keep it to 2. So 0.16, and it's meters per second is our average speed. Watch the video again if you have questions, and let me know if you need anything clarified.